Welcome to School of Advanced Chemistry. I'm Khadar Choktai and you're watching my YouTube channel. I'm going to explain the second portion of crash course for bonding and structure for IGCSE and O-level chemistry students. Let's get started. First of all, I'm going to explain a reason for the electrical conductivity in different sort of substances. Number one, element. Number two, compounds. Basically, element can conduct electricity because of movement of electrons, free electrons or delocalized electron. But compounds may conduct or can conduct electricity because of having free opposite ions, free both positive and negative ions. So first of all, you will have to categorize the question. Either he is asking about element or compound. If the question is about element, then basically you will write the answer. If element is supposed to conduct electric current like graphite, so it is having free or mobile or delocalized electron. If element is not able to conduct electricity like diamond, then you will write it's not having, there is absence of free, delocalized or mobile electrons. Same is the case in case of compound. If a compound is able to conduct electricity, then it will be having free opposite ion, mobile opposite ion, mobile positive and negative ion, freely moving positive and negative ion. For example, NaCl, sodium chloride, is an ionic compound. In case of solid, there are opposite ions, yes, but ions are not freely moving. In case of NaCl solid, ions are static. They are not moving around. But in case of molten NaCl, ions are freely moving. In case of aqueous NaCl, when NaCl is dissolved into the water, then again there is the formation of free moving opposite ion. Sodium positive ion, Cl negative ion, both types of ions are present over here. So if the compound is having ions, even you are not dealing with ionic compound. For example, I am going to dissolve aqueous solution or making aqueous solution of sulfuric acid. H2SO4 is not an ionic compound. It's a covalent compound. HCl is not an ionic compound. HNO3, all acidic solutions are basically covalent compound. Even then, you can say they are having free opposite ions in the solution. So they are good conductor of electricity. They can conduct electric current very much appreciably. But if the compound like glucose, like iodine, like ethanol, if they are not going to make any sort of positive or negative ion into the water, so they won't conduct electric current. They will not conduct electric current. They will not conduct electricity from their solution. If element is present in the question, and if it is conducting electric current, simply speaking, it is having free electrons, delocalized electron, and so on. If a compound is capable to conduct electricity, then simply it means it is having free moving opposite ions, free or mobile ions, and so on. Next one, let's do the past paper questions practice. What are the basic typical, or you can say the most oftenly asked question in your past paper history? Let's talk about it and how to write their answer, how to write a comprehensive answer, and especially I'm going to write it model answer over here. Let's see in each case. For example, in this question, explain in terms of structure and bonding why zinc chloride has high melting point. Now, you know what is the nature of this compound. Zinc chloride is a compound. What is the nature of this compound? It is basically, as it is having high melting point, so it will be definitely an ionic compound. Zinc chloride is an ionic compound and it is having joint ionic structure. Zinc ion, chloride ion are attracting each other by the strong ionic bond. Number one, for 1 mark. Number two, The structure of zinc chloride is a giant structure. Mean there are numerous quantities of the zinc positive ion, 2 positive ion, and Cl negative ion. So the model answer is, the basic answer is, as it is an ionic compound having giant ionic structure and strong ionic bonds. Or you can write strong electrostatic forces of attraction between the opposite ions. You can write ionic bond, over here. If you are not going to write the detailed answer, then you can write the strong ionic bond instead of electrostatic force of attraction between the opposite ions. However, the last one, you will have to write the conclusive point. This makes ions difficult to separate, hence more heat is required. So that's why magnesium chloride, zinc chloride, all type of ionic compound. If there is an ionic compound, so ionic compounds, giant structure, strong ionic bonds, and that's why these strong ionic bond and giant structure make it more difficult to melt down. So it is having high melting point. The next question. This question is about metals and metal compounds described with the aid of label diagram in the structure and bonding in the metal for 3 marks. So you are supposed to write the structure of a typical metal. What is the basic requirement to write the structure? What are the basic portion you can say? You will draw circles for the positive ion. Proper circles in a regular pattern, in regular layers, in regular arrangement. Then you will draw the free or delocalized electron, and then you will label them out. Labeling layers of the static positive ion and free moving electron. At least you should draw 3 to 4 layers for the metallic structure. For example, like that. So these are the circle having exhibiting the basic metallic positive ion, and here are basically delocalized electron surrounding these layers of the static metal positive ion. So layers of the static positive ion, label number 1 you can say. The second labeling, C of mobile electrons, and here are the regular structure, giant pattern of this one. So you can write the layer of static positive ion, and you can add in giant structure. Giant structure. So once again, layer of the static positive ion and giant structure, that is layer 1, layer 2, layer 3. And here are free moving electron, free delocalized electron. Second name, free mobile electron. You can write, 2 or 3 different possible options, and you will apply, or you will show the random presence of electron usually. So this is the typical model answer to write the structure, to explain the structure, to describe the structure of a metal. Next one. Nitrogen exists as diatomic molecule N2, dot in cross diagram to show the bonding in N2. Show only outer shell electrons. So basically, as you know, N2 nitrogen is diatomic molecule, and it is having triple bond between 2 nitrogen atoms. So first of all, draw the Lewis diagram, triple bond. Then you can change these bond into dot and cross. First of all, as I told you, nitrogen is triple bond over here. Each nitrogen is making 3 covalent bond. Each nitrogen is contributing 3 electron. For example, this nitrogen is contributing 3 electron. I'm exhibiting the electron of this nitrogen by dot. And the left is also contributing 3 electron for the covalent bond formation. And these electrons are represented by the crosses. So this cross and dot, dot cross is the representation of the bond pair. Cross from one atom, dot is the electron from the other atom. So this dot and cross is the exhibition of shared pair, bond pair of electron. And finally, if I'm removing these line, these covalent bond, finally I'm having this structure. This is the true dot and cross diagram of a covalent molecule like nitrogen. Next one. Explain in terms of structure and bonding why nitrogen has low melting point. Structure and bonding. Again and again, they are asking, usually they are asking to quote the reference of structure and bonding. In terms of structure and bonding, basically the structure of N2. N2 is having simple molecular structure. N2 is having simple molecular structure. That's why it is having low melting point. So it's a covalent molecule having simple molecular structure. So there are weak intermolecular forces between them. Number one, it is a simple covalent molecule. Its structure is simple covalent structure. Number two, you can say there are weak van der Waals forces. There are weak intermolecular forces between one N2 and other N2 molecule. I mean, each two neighboring N2 molecule are experiencing the weak forces. These are said to be intermolecular forces. They are also said to be van der Waals forces. So less energy is required to break them out, to overcome these forces, and so on. Next one, again, it's labeling the diagram of metallic bonding in solid aluminium for 2 marks. Same is the case over here. Same step will be repeated in this structure. Static positive ion layers are the layers of static positive ion for aluminium. And there must be the presence of free or delocalized electrons. So layer structure, sea of electrons, and moreover, you can draw three positive charge in each circle that is exhibiting the aluminium. As aluminium is having 3 positive ion, I mean the charge on the aluminium is 3 positive, so you can exhibit like that, 3 positive. And you can also write like that, aluminium 3 positive, aluminium 3 positive, same as the case over here. So they all are having these circles. I mean, this is a demonstration of static positive aluminium 3 positive ion and so on. At least 3 to 4 layer, I mean, must be shown in your question, in your answer, I mean. And layers, structure, sea of labeling, I mean, sea of mobile electron, layer of static positive ion, layer, static positive ions, structure that is having a regular pattern that is said to be metallic lattice, full marks, even 3 marks. Next one. Why molybdenum has much higher melting point than aluminium? This is a simple comparison between the aluminium and molybdenum. I mean, this is the contest between two metals. Both are having same structure. Both are called metals. It's a metal. It's a metal. And now he is saying that molybdenum is having much higher melting point than aluminium. It means that if the melting point or the boiling point of the one of the metal is higher, it means that no doubt it is having the same structure. Both are having the same structure. Both are having the same giant metallic structure. But there is the difference between the strength of metallic bond. They are not having same magnitude of metallic bond in them. So they both are having different strength of metallic bond. Number one. Number two, the molybdenum in this case that is having much higher melting point, then it is having more delocalized electron than other one. I mean, indirectly speaking, the strength of metallic bond is going to depend upon the number of delocalized electrons. For example, magnesium can delocalize 2 electrons as it is having 2 electrons in its valence. Sodium can delocalize 1 electron. Aluminium can delocalize 3 electrons. So sodium, magnesium, aluminium, which one is delocalizing more electron? That is aluminium. So aluminium will make stronger metallic lattice. It will make stronger metallic bond. So once again, much stronger attraction between mobile electrons and the positive ion. That is the second name of metallic bonding. Then the second point is basically there are more delocalized electron, more number of delocalized electron in molybdenum as compared to aluminium. Hence, molybdenum needs more energy to rectify these forces of attraction between static positive ion and its mobile electron. Next one. Titanium 4 chloride is a colorless liquid and that has low boiling point. Liquid. Number one, colorless liquid. Titanium chloride. Titanium is a metal, even though its compound is liquid and it is having low boiling point. These are the two indications about its nature of bonding and structure. Suggest structure and bonding. Obviously, if it is liquid at room temperature, it is having low boiling point, then it means that it is having simple molecular structure in spite of having metal and non-metal. But this is not an ionic compound. It is having simple covalent structure and it is a covalent molecule. It is having covalent bond. TiCl4. This is the basically one of the possible proposed structure, and this is a simple molecular structure, and this molecule is having are making covalent bond. Next one. Use ideas about structure and bonding suggest why calcium phosphate Ca3PO4, basically that is again an ionic compound, has a high melting point. So once again, I'm going to concentrate on the nature of compound. It is an ionic compound. As you know, there are two types of compounds: ionic compound, covalent compound. Ionic, covalent. So as it is having high melting point and metal is also present in this compound, in this salt, so it means that it is an ionic compound. So as it is ionic compound, its structure is joint ionic structure. There are strong ionic bond. So joint ionic structure, strong ionic bond between these two ions, I mean calcium ions and phosphate ions. So these ions are difficult to separate. So more energy, more heat energy is required to separate them. Next one. Glass is made from sand, SiO2, that is the second formula of sand. Explain in terms of structure and bonding. Structure and bonding. Again and again, they are asking structure and bonding. Why sand has high melting point? You know, SiO2 is a macromolecular structure. SiO2 is a macromolecule. It is having macromolecular structure, or its second name is joint molecular structure. So once again, it is having joint structure. The second one, there are strong bonds between silicon and oxygen atom, right? Silicon, oxygen, and so on. So there are silicon, oxygen, strong covalent bonds, number one. Number two, the structure of this whole unit is the macromolecular structure. So large heat or high amount of heat is required to break these strong bonds in a joint structure. That is the appropriate answer. The next one is using the idea about structure and bonding, suggest why silane has a low boiling point. Silane basically, again, as there is an indication of low boiling point, then simply it means if it is having low boiling point, then it must be having simple molecular structure, covalent bonding, weak van der Waals forces, and so on. So its structure is simple molecular structure, and there is the breakage of weak van der Waals forces. In case of simple covalent molecule, when we are going to boil them or we are going to melt them out, so there is no cleavage of, there is no breakage of pure chemical bond. There is just detachment of the molecule. Molecule basically move away from each other intermolecular forces. The forces of attraction between the molecules are overcome by the heat. So less energy is required and so on. Sulfur dioxide, SO2, is a gas you can imagine, and you are familiar with this. SO2 has low melting point. Once again, SO2, simple covalent molecule. It is a simple covalent molecule are having the simple molecular structure, and weak van der Waals forces are present, or weak, you can say, intermolecular forces are present between SO2 molecules. So SO2 molecule attract another SO2 molecule by the weak force. When you apply the heat, these forces are rapidly, easily can be broken down. So it is having less melting point and less boiling point, even in case of, if the SO2 is solid, then its melting point will be less. If SO2 is in a liquid state, then its boiling point will be less. Now, the next one portion is basically, I have taken it from organic chemistry. Organic compounds are also covalent compounds. And usually, they are also simple molecular compounds. They are also simple molecular compounds. So, question number 1, alkenes are the homologous series of the unsaturated hydrocarbons. Name the alkene which has only 3 carbon atoms. 3 carbon starting from prop, alkene, ene, propene. Basic name is propene. Data structure of an unbranched and branched alkene. So branched and unbranched alkene, basically, we are supposed to draw the displayed formula. For example, I am drawing in first portion, this is called butene. But1-ene or butene. Simple straight line, unbranched structure. In branch structure, its name is 2-methyl-prop-1-ene. 2-methyl-prop-1-ene. Here is the branch. This is the branch, and there is no branch. All carbons are lying in the same straight chain, on a same road, you can say. So this is unbranched structure. Basically, my concern is to demonstrate the displayed formula. How to represent the covalent organic molecule? Simply, you will have to draw a displayed formula, a Lewis diagram, and so on. Next one is to draw the structure of propanoic acid. Again, prop mean 3, ane mean carbon-carbon single bond, OIC acid mean COOH group. 1 second. Prop mean 3 carbon should be there. Ane mean carbon-carbon single bond should be there. OIC acid mean COOH. So this is the complete picture of, complete diagram of displayed formula of propanoic acid. Next question, explain in terms of structure and bonding why diamond has such high melting point. Again, what is the nature of diamond? Diamond is a giant macromolecule, and it is having strong CC bond, strong carbon-carbon bonds. You can say the strongest carbon-carbon bond. It's a giant structure, or the macromolecular, giant macromolecular structure, giant or macromolecular structure. Here are strong covalent bonds, CC, strong carbon-carbon bonds. So high amount of energy is required to break this carbon-carbon bond in a giant structure. That is an appropriate, that is a model answer to write the basic reason why the macromolecules are having high melting or high boiling point. Group 7 elements are shown over here. A table is given. In this case, there are the different melting points, boiling point, electrical conductivity, elements, and so on. So elements, their density, melting point, boiling point, electrical conductivity. Use the information in the table to explain how the structure and bonding in the oxygen differ from the structure of bonding in polonium. This polonium is having high density. This is having high density, high melting point, high boiling point, and good electrical conductivity. But oxygen is having low density, minus melting point, low boiling point, and very poor conductivity. So, according to these informations, it means that polonium as a pure element is a metallic element, and oxygen is non-metallic. So metallic element is having metallic structure, giant metallic structure with a strong metallic bond. Oxygen is having simple molecular structure and weak intermolecular forces are over here. Again, because of the poor conductivity, low melting point, and low boiling point, low density of the oxygen suggests that it is having simple molecular structure with a weak van der Waals forces. While good conductivity, high melting point, high boiling point, high density of the polonium shows it has strong metallic bonding in its lattice and it is having giant metallic structure. Next one, polyethylene is made from the ethene monomers. Again, it's an organic compound basically. And draw the structure of ethene showing all atoms and all the bond. So it's very much simple, 2 carbon, 4 hydrogen, carbon-carbon double bond. It is said to be displayed formula. It is said to be a Lewis structure and so on. That's all for today. That's all for this crash course revision and practice.